This assessment asks us to calculate oxidation numbers for several atoms in this steroid molecule. We'll do it for A here. Now, the way we calculate oxidation numbers is we start by looking at all of the different bonds to this carbon and imagine hypothetically whether the 2 electrons in a given bond are owned by the carbon, shared equally with the other atom, or owned by whatever other atom is attached. And this is going to come down to electronegativity. So let's look at, if we consider this carbon-carbon bond here, we would say that those 2 electrons, because it's between 2 identical atoms, those are going to be shared equally. So carbon picks up no additional negative charge as a result of that bond. So we could put a 0 on that carbon as a result of this particular bond. Do the same thing here because this is a carbon-carbon bond. We'll put another 0 here and a 0 on that carbon, meaning that these 2 electrons are shared equally between the 2 carbons. When we come over to the oxygen, oxygen is more electronegative than carbon. So oxygen, for each bond in the double bond, oxygen is going to get a -1 charge and carbon will get a +1 charge. So we do that here for the first carbon-oxygen bond. We do it for the second to give a -1 and another +1 to carbon. And so we see that this does 2 things. One, this shows us that the oxidation number for oxygen is -2, which is pretty standard for oxygen, but that's not what this question is asking. This question is asking about carbon. And we noted that carbon got 0 from carbon, 0 from the other carbon, +1 and +1 from each of the 2 bonds to oxygen. We sum those. That carbon has an oxidation number of +2.